Welcome to Numbers Simplified. In this channel, we seek to simplify and solve numerical problems. Today, we'll be looking at the division of polynomials, but focusing on the partial fractions. So let's have a recall from the division of polynomial videos. We have a list that covers the division of polynomials, all the types of polynomials. But remember, we have p of x, which is the polynomial, being divided by the d of x, which is known as the divisor, being equal to the quotient. So we have p of x as the dividend and d of x as the divisor, so that we get a quotient q of x. Now, we are saying that with the p of x as the subject, we can actually have p of x being equal to q of x times d of x plus r of x, which is the remainder. Now, what are partial fractions? It is actually a way of decomposing algebraic fractions into two or more partial fractions. We cover 4 cases of partial fractions. 3 of them are from proper algebraic fractions, with the other being an improper algebraic fraction. So now, let's look at the terminology. For an algebraic fraction given as p of x divided by d of x, A, if the degree of p of x is less than the degree of d of x, then the fraction is said to be a proper fraction. However, let's look at case B. If the degree of p of x is greater or equal to the degree of d of x, then the fraction is an improper one. Make sure to check out our videos on polynomial divisions for more on the terminology. Let's look at case number 1. We have proper fractions with distinct linear factors or denominators. So let's look at a basic scenario. We have px plus q all over ax plus b times cx plus d. We are saying that this is equivalent to capital letter of A divided by ax plus b plus capital letter of b divided by cx plus d. We label this as equation 1 using the Roman numerals, where our q, p, a, b, c, d, and capital letter A and b being elements of real numbers. Let's look at example 1. Express as a partial fraction x minus 1 divided by 3x minus 5 times x minus 3. The solution. Recall from formula 1, we can actually express this algebraic fraction in terms of the form x minus 1 divided by the divisor being equivalent to a over 3x minus 5 plus b over x minus 3. With that, we multiply both sides by the product of the divisors on the left-hand side. When we do that, what would happen then is the divisors are cleared from the left-hand side, so that we have x minus 1 being equivalent to the a's, and we see that we can actually cancel out the common factors in the numerator and the denominator, so that we finally have x minus 1 is equivalent to a times x minus 3 plus b times 3x minus 5. Let's call this equation star. We are calling that equation star because we will refer back to this equation. Let's move on. So what we have on the left-hand side is the question and the key point that we obtained from the previous page. Great, so we continue with our solution in red. So in solving for a and b, we can actually eliminate a or b, but in our case, we start by eliminating a. So we eliminate a by setting x to be equals to 3. So in this case, we substitute for x is equals to 3 in equation star, so that we have 3 minus 1 is equal to a times 3 minus 3 plus b times 3 times 3 minus 5. So we can see that that eliminates the a because it goes to 0, so that we have 2 is equals to 4b, so that our b becomes 1 over 2. So we move on to eliminate b now that we have the value of b. So we can set the x to be 5 over 3. This one, we get it from 3x minus 5 is equals to 0. So we set that bit to be equal to 0 because that's the bit that is multiplying with the b. So we set it to 0, we solve for x, we get the value of x, which makes that expression 0, and that's how we eliminate the b. Then we substitute this value for b into equation star. So when we do that, we are going to have that bit over there, and it's clear to see that our b is eliminated, so that we have 2 over 3 is equals to minus 4 over 3 a, so that our a comes out as minus 1 over 2. Then we are saying we are going to have x minus 1 all over 3x minus 5 times x minus 3, which was the question, being equivalent to a over 3x minus 5 plus b over x minus 3, and we have the values of a as well as b. Substituting for these values, we are going to get that expression there. So that's how we express that algebraic fraction as partial fractions. Great. We move on to example 2. So with example 2, we have expressed as a partial fraction 6x squared plus 5x minus 2 all over x times x minus 1 times 2x plus 1. Solution. So we also consider the formula 1. We can actually express the fraction in the form that which we have as the question, being equivalent to a over x plus b over x minus 1 plus c over 2x plus 1. As before, we multiply both sides by the denominator on the left hand side, which is x times x minus 1 times 2x plus 1. In doing so, we are going to have 6x squared plus 5x minus 2 on the left hand side being equivalent to that, and we are going to label that as equation star. Why? We know that we will refer back to this equation or to this identity. So this is an identity since we have the equivalent rather than the equal to sign. So in solving for a, b, c, we can actually eliminate a and c by setting x minus 1 is equals to 0 for the first part, because we know that in doing so, we can actually eliminate every term that is being multiplied by x minus 1. So these terms include the a and the c, so that we are left with the b. So we find the value of x at which this one is set to 0, so that we get our x as 1. So we substitute that 1 into equation star. In doing so, we see that we actually eliminate all the other terms, so that we are only left with the b term. Simplifying further, we are going to have 9 is equals to 3b, implying that our b is equals to 3. We move on to eliminate b and c this time around by setting x is equals to 0. We see that if we do that, we can actually eliminate all the terms that are multiplied with the x on the right hand side. These are b and c. So when x is 0, we substitute that value into equation star. We are going to have that. And simplifying further, we are going to have minus 2 is equals to minus a, implying that a is equal to 2. We use the same approach in order to eliminate a and b by setting x is equal to minus 1 over 2 and substituting it into equation star. I'm sure we see where we got this x is equal to minus 2. We just set the 2x plus 1 being equal to 0. We solve for x. We get the value of x, which eliminates all the terms that are multiplied by 2x plus 1. So substituting into equation star, that is what we would get. And simplifying that further, we would get our c being equal to minus 4. Great. So that is the question. Then substituting back into the format that we were given, or the format that we know from Formula 1, we have our a, b, c terms. So our final answer becomes that when we substitute for the unknowns, which were a, b, and c, all capital letters. So that is the answer there. Great. Let's look at case number 2. Case number 2 is such that we are looking at proper fractions with repeated linear factors or denominators. So we have px plus q divided by ax plus b squared times cx plus d, this being equivalent to capital letter A divided by ax plus b plus capital letter B divided by ax plus b, this time around squared, plus capital letter C divided by cx plus d. Let's label this equation 2 in Roman numerals, where recall our P, Q, small letter A, B, C, D, and capital letter A, B, C being elements of real numbers. And take note, the squared divisor is repeated. One not squared and the other squared. Like in the first fraction, the ax plus b is not repeated, so it's not squared, plus b, capital letter B, over ax plus b, this time around squared. So take note of the difference. So equation 1 is different from equation 2 in the sense that one of the divisor is squared and we say that is repeated. So that's how we write it in this particular format. Example 3. Express as a partial fraction 2x over x plus 2 squared. So the solution. From formula 2, we can express the fraction in the form 2x over x plus 2 all squared is equivalent to a over x plus 2 plus b over x plus 2 squared. And as usual, we would need to clear the fractions or clear the denominators. We do so by multiplying both sides by the denominator of what is on the left-hand side, and that is x plus 2 squared. In doing so, we are going to have 2x being equivalent to a times x plus 2 plus the capital letter B. Let's label this equation star because we would refer back to it in solving for a and b. So we know that we can actually eliminate a by setting x is equal to minus 2 and substituting it into equation star. In so doing, we are going to get 2 times minus 2 is equal to capital letter B, and that B becoming minus 4. Great. So we have on the left-hand side the question and the key points that we have obtained so far. We have our equation star as well as the B that we have obtained of minus 4. Moving on, we can set any value which is not minus 2. So we can set any arbitrary value for x which is not minus 2. In this case, we are going to use x is equals to 0. We sub it into equation star with the value of b. Then we obtain 2 times 0 is equals to a times 0 plus 2 minus 4, so that we get 0 is equals to 2a minus 4, and the a becomes 2. Now that we have obtained a and b, therefore, substituting these values into formula 2, we are going to have our answer given in that particular way. As easy as that. Let's take a look at example 4. So we are expressing this as a partial fraction, 36x squared plus 2x minus 4 all over 2x minus 3 times 2x plus 1 squared. So the solution, we would recall from formula 2 that we can actually express this fraction in the form where we have the left-hand side being the question itself, being equivalent to capital letter A over 2x minus 3 plus capital letter B over 2x plus 1 plus capital letter C over 2x plus 1 all squared. And I'm sure you know the next thing. Multiplying both sides by the denominator of what we have on the left-hand side in order to clear the fractions. So in doing so, we are going to multiply both sides by 2x minus 3 times 2x plus 1 squared, so that we have 36x squared plus 2x minus 4 being equivalent to a times 2x plus 1 squared plus b times 2x minus 3 times 2x plus 1 plus c times 2x minus 3. That will be labeled equation star. The next thing then would be to eliminate a and b by setting x equals to minus half and substituting into equation star. We are going to have it in that way. So simplifying that further, then we would have 9 minus 1 minus 4 is equals to minus 4c, meaning that our c is equals to minus 1. We move on to eliminate b and c. So we identify the expressions that affect b and c, and we see that from equation star, the b and c have 2x minus 3. So setting that to 0 and solving for x, we get the x of 3 over 2. And substituting that value into equation star, we are going to have that. And simplifying further, we would have 81 plus 3 minus 4 is equals to 16a, implying that our a is equal to 5. Great. We move on with our solution. So we have the question and the key points. So the equation star, the c we obtained of minus 1 and the a of 5. To find b, we set x to any value, which is an arbitrary value. So in this case, we set it to x is equals to 0 and substitute it into star with the values of a and c. In doing so, we are going to have that. And with that, we get minus 4 is equals to 5 minus 3b plus 3, meaning that our b is equal to 4. So when we get the 4, then we would recall from formula 2 that we had expressed this in that particular format, and then substituting for the a, the b, and the c, we are going to have our final answer as that. Let's move on to case 3. We are still looking at proper fractions with a quadratic factor that cannot be factorized. For instance, we have px plus q all over ax plus b times cx squared plus d being equivalent to capital letter of a over ax plus b plus capital letter bx plus c all over cx squared plus d. We label this equation 3, in Roman numerals, where, of course, our P, Q, A, B, C, D, and capital letters A, B, C being elements of real numbers. Let's look at example 5. Expressed as a partial fraction, 3x squared plus 4x plus 17 all over 2x plus 1 times x squared plus 5. The solution. So recall from formula 3, we can express the fraction in the form. So we have that which we had as our question, then being equivalent to capital letter of A over 2x plus 1 plus bx plus c over x squared plus 5. Take note, we're doing so because we cannot factorize x squared plus 5. You can recall from our previous videos where we looked at quadratic factorization. Yes, in as much as we can try to use other methods, but in terms of factorizing this will be impossible. So let's stick to what we have. We move on to what we have been doing in the past. We multiply both sides by the denominator of the term we have on the left-hand side. That is the denominator 2x plus 1 times x squared plus 5, because we want to clear the fractions. In doing so, we are going to get 3x squared plus 4x plus 17 is equivalent to capital letter A times x squared plus 5 plus bx plus c all multiplied by 2x plus 1. This time around, we use the comparing the coefficient approach, unlike the other sections where we were just eliminating just like that. But I encourage you also to check out our video on comparing the coefficient approach. We cover this method in great detail. Let's move on. We expand the brackets or the parentheses, that's the first thing we do, and group the like terms in order to get 3x squared plus 4x plus 17 being equivalent to ax squared plus 5a plus 2bx squared plus bx plus 2cx plus c. Now we move on to group the like terms so that we have what we had previously on the left hand side, and then we would have a quadratic equation on the right hand side where the coefficient of x squared is capital letter A plus 2b, the coefficient of x is capital letter B plus 2c, and the constant term is 5a plus c. Let's label this equation star. We compare the coefficients of x squared of x and the constant terms from equation star. Then we see that for x squared, 3 is equal to a plus 2b, that is our equation 1. Then we compare for the x, the coefficient of x. We have 4 is equal to b plus 2c. Let's label this equation 2. And for the constant term x to the power 0, we have 17 is equal to 5a plus c. This one will be equation 3. So as we can see, we have simultaneous equations. So we are going to solve these since we have 3 unknowns with 3 equations. We have the question on the left-hand side as well as the key points. So recall equation star and the simultaneous equations 1 up to 3. So in solving the simultaneous equations, let's start by having equation 1 minus 2 times equation 2. Recall from how we solve simultaneous equations. So in this case over here, we are trying to eliminate one of the variables. So if we multiply equation 2 by 2 and then subtracting that from equation 1, we are simply eliminating the variable b. So in this case, we are going to have 3 minus 8 is equals to capital letter A plus 2b minus 2b minus 4c. So that we have minus 5 is equals to A minus 4c, this being equation 4. With this then, we are saying equation 4 plus 4 times equation 3. In this case, we are going to eliminate c, so that we have minus 5 plus 68 is equal to A plus 20A plus 4c minus 4c. So in that case, we are going to have 63 is equal to 21a, implying that our a is equal to 3. Then we substitute for a into equation 4. Doing so, we are going to obtain minus 5 is equal to 3 minus 4c, so that we get minus 8 is equal to minus 4c, and c becomes 2. So substituting for the c into equation 2, we get the b that is equal to 0. Now, recall from formula 3, we are substituting these values that we obtained for our variables. A was 3, b was 0, and c was 2. So recall, that is what we had as that formula. So substituting for these values means that we are going to get our answer given as that over there, since our b is equal to 0. Let's move to equation 6. So we are going to use the same logic we used in example 5. So we have expressed as a partial fraction 2x squared minus 6x minus 9 all over 3x plus 5 times 2x squared plus 1. So for the solution, from the formula 3, we can actually express this fraction in the form that on our left hand side, which was from the question itself, being equivalent to capital letter A over 3x plus 5 plus bx plus c all over 2x squared plus 1. And as usual, we will multiply both sides in order to clear the fractions by the denominator of what we have on the left hand side, that is 3x plus 5 times 2x squared plus 1. In doing so, we are going to get this new expression, which is actually an identity, because we still have that which is equal to that, the left hand side being equal to the right hand side. So 2x squared minus 6x minus 9 is equivalent to a times 2x squared plus 1 plus bx plus c times 3x plus 5. So we move on to expand the brackets or the parentheses, recall, and grouping the like terms in order to get 2x squared minus 6x minus 9 is equivalent to 2ax squared plus a plus 3bx squared plus 5bx plus 3cx plus 5c. Now we want to form a quadratic equation, a quadratic expression on the right hand side. So we group the like terms according to the x terms, starting from x squared up until we get to the constant term. So in this case, we are going to have as the coefficient of x squared 2a plus 3b. Now the coefficient of x, 5b plus 3c, and the constant term being a plus 5c. Let's label this equation star because we are going to refer back to it as usual. Now we compare the coefficients of x squared, x, and the constant terms from equation star or identity star. This one is an identity. So now for x squared, we have 2 is equal to 2a plus 3b. Let's label this equation 1. Now this one is an equation, it's not an identity, please take note. And x, we have minus 6 is equal to 5b plus 3c. This one becomes equation 2. And for the constant term, or x to the power 0, we're going to have minus 9 is equal to a plus 5c. Let's label this equation 3. So we have simultaneous equations 1 up to 3. Right, so recall the key points here. We have the equations 1 up to 3, and then we continue. We want to eliminate one of the variables since we have 3 unknowns and 3 equations. So we are using the elimination method. Equation 1 minus 2 times equation 3. We are going to get 2 plus 18 is equals to 2a minus 2a plus 3b minus 10c. Simplifying further, we are going to get 20 is equals to 3b minus 10c. Let's label this equation 4. Great. With this equation 4, then we are saying equation 2 multiplied by 3 minus 5 times equation 4, we are going to have minus 18 minus 100 is equals to 15b minus 15b plus 9c plus 50c. With that, we are going to get minus 118 is equals to 59c, implying that c is equal to minus 2. So substituting for c into equation 2, and recall our c is minus 2. So we're going to get minus 6 is equal to 5b plus 3 times minus 2, so that we get 5b is equals to 0. Just like in the previous question, this is just a coincidence. It's not like b is always equal to 0, but b is equals to 0 in this case. And substituting for b is equals to 0 into equation 1, we get 2 is equals to 2a, implying that our a is equals to 1. So therefore, this implies that the question can be expressed as partial fractions. That is to say, it's equivalent to that which we have on the right-hand side. We are done with the proper fractions. Let's look at case number 4. Improper algebraic fractions. So to decompose these kind of fractions, we need to first express them in the mixed fraction form. That is to say, we have p of x divided by d of x. Remember, our p of x is the dividend, d of x is the divisor, being equal to the quotient q of x plus r of x over d of x. R of x is the remainder over the divisor. So that is how we would need to carry out this first. From there, we now apply the proper algebraic fractions decomposed to partial fractions. So to easily do so, that is to make improper algebraic fractions be mixed fractions, that is with the quotient plus the remainder over the divisor. Please check out our videos on polynomial divisions for more. We covered the synthetic division, part 1 and part 2. We also covered long division. We had comparing of coefficients and the area model. All this can help out in making sure that you have proper algebraic fractions. Anyway, let's dive into example 7. So we have the question, find the values of a, b, c, and d such that 4x cubed minus 9x squared plus 11x minus 4 all over x squared times 2x minus 1 is equals to, or rather equivalent to, a plus b over x plus c over x squared plus d over 2x minus 1. The solution. Evidently, we can see that the algebraic fraction is an improper one, since the degree of the dividend is 3 and that of the divisor is 3. So I encourage you to just check out the first section where we talked about proper and improper algebraic fractions. So in this case over here, we say this one is an improper one, and we need to first express it in terms of the quotient plus the remainder over the divisor. So expanding the whole divisor first, because we see that that divisor is given in two parts. We are going to have 2x cubed minus x squared. Therefore, it means that we are going to have our fraction, algebraic fraction for that matter, given in that way. Fine, that was the first part. Now, we did that because we would need to divide with the whole denominator. So in this case, I'm going to use the long division. So I encourage you to check out our long division approach or method in order to gain more out of it. So in this case here, we're just going to cruise over the division method because that's not the main point of this video. We are focusing on partial fractions. So recall, we divide with the leading term into the leading term of the dividend so that we get 2 over here. We see that when we say 4x cubed divided by 2x cubed, we get a 2. Then we multiply that 2 with every term in the divisor. We are going to have 4x cubed minus 2x squared. Then we subtract that which we obtained as the result of the quotient times the divisor from the dividend. Then we get this minus 7x squared plus 11x minus 4. Then we see that we can no longer divide this remainder with what we have as the divisor. So that will be the remainder. So then it means that our question can actually be expressed as 2 plus minus 7x squared plus 11x minus 4 over x squared times 2x minus 1. Awesome. So we will keep the question and the key points. Remember, from the key points, it implies that our a in this case is equals to 2, according to the format given from the question. Great. So now we consider the algebraic fraction term, which is now a proper fraction. So meaning that we can actually decompose this into partial fractions. Right, so with that, we check out the divisor and recall this divisor is similar to the divisor we looked at in our case 2. So that was using formula 2 in Roman numerals. So we can express this particular algebraic term to be equivalent to b over x plus c over x squared plus d over 2x minus 1. And of course, we would want to clear the fractions. So we multiply both sides by the denominator of what is on the left-hand side. So in doing that, we are going to have minus 7x squared plus 11x minus 4 is equivalent to bx times 2x minus 1 plus c times 2x minus 1 plus dx squared. Let's label this equation star or identity star because we will keep on referring back to it. Right, so we can eliminate b and d when we set x is equals to 0 in identity star. So with that, we are going to get minus 4 is equals to c times 2 times 0 minus 1, implying that our c is equal to 4. We move on to eliminating b and c. So we set x to be 1 over 2 in identity star because we can see over here that the terms that are affected by 2x minus 1 are b and c. And we set that to 0. We solve for x. We get our x as 1 over 2, which we substitute into identity star so that we have that bit over here. Simplifying further, we are going to get minus 7 over 4 plus 3 over 2 is equals to 1 over 4 d. And simplifying further, we have our d as minus 1. Great. Now that we have our a as 2, our c as 4, our d as minus 1, we set arbitrary values for x apart from 0 and half because we know that if we substitute x with 0 or half, we would go back to the situations we have for C and D. So in that case, by arbitrary, we mean any values of x apart from 0 and 1 over 2. So let's choose x is equals to 1. So with that, we substitute into identity star, and also we can actually substitute for the values of C and the values of D, which were 4 and -1 respectively. In doing so, we're going to have 0 is equals to b plus 4 minus 1, implying that our b is equals to -3. With that, it therefore means that our a is 2, our b is -3, and our c is equal to 4, and our d is equals to -1. That's how we solve this kind of problem. Let's look at the last example for the day. Now, this one is an interesting one because it involves a lot of concepts. We have the division of polynomials, we have the factor and the remainder theorem, we also have the partial fractions concept. Let's look at the question itself. The polynomial p of x is equal to 2x cubed plus 5x squared plus ax plus bx. So these are small letters which we have to obtain from part A. Then we are told that this polynomial p of x is exactly divisible by 2x plus 1 and leaves a remainder of 9 when divided by x plus 2. Now recall, one is a factor and the other is a divisor. Recall from our previous videos on division of polynomials, and I encourage you to check out these videos because we talk a lot about such terminology. So for the b part, we are expected to factorize p of x completely, that is to have separate parts. And then the c, we are supposed to express 120 over px in partial fractions. Let's look at the first step. So for solution A, I would also encourage you to check out our factor and remainder theorem video. Since 2x plus 1 is a factor, then lambda 1 is equals to -1 over 2. We got this from setting 2x plus 1 is equals to 0 and solving for x, and that x we make it the lambda 1 or lambda 1. So we get lambda 1 as -1 over 2. And then the p of lambda 1, so implying that where we have x, we're just substituting with the value of lambda 1. We get to that, and that should be equal to 0. Why? Because 2x plus 1 is a factor, meaning that it is divisible, or rather p of x is divisible by 2x plus 1. So it divides into p of x without leaving any remainder. That's why we set this one to 0. So simplifying further, we are going to get that, and then of course clearing that and expressing that in terms of a's and b's without fractions. We are going to get -a plus 2b is equals to -2, and let's label this equation 1 for easy of reference. So now for divisor x plus 2, we have lambda is equals to -2. So we use the same logic in order to get the lambda 2. So we're saying that p of lambda 2 is given by that, where we have x, we're just simply substituting by -2. And this one should be equal to 9 because we are told that this 1 over here, the x plus 2, is just the divisor, meaning that it leaves a remainder and the remainder of 9. So with that in mind, we simplify further so that we get to the final step of -2a plus b is equals to 5. Let's label this equation 2. So we've got two equations, two unknowns, so we can find a and b. So in this case, we are saying that from equation 1 and equation 2, we can have equation 2 minus 2 times equation 1, so that we eliminate the a. We are going to have b minus 4b is equals to 5 plus 4, which simplifies to minus 3b is equals to 9. Then our b is equals to minus 3. Now substituting for b into equation 2, we get minus 2a minus 3 is equals to 5. So minus 2a is equals to 8. And then a is equals to minus 4. So implying that p of x is equals to 2x cubed plus 5x squared minus 4x minus 3. That is the answer to part A. Moving on to part B. And also, I will have this p of x on the left-hand side so that we recall the values of a and b in factorizing completely. So with equation B, since 2x plus 1 is already a factor of p of x, we find the coefficient by the synthetic division. Of course, we can use any other method, but I chose to use the synthetic division for it's easy to use and it's quick to get the answer. So in this case, we are going to have the coefficients of the x terms being arranged in that manner from 2, 5, minus 4, minus 3. Then we have lambda 1, which was minus 1 over 2, which we obtained from the factor 2x plus 1. Then we drop the first term, which is 2. 2 times lambda 1, we get minus 1. 5 minus 1, we get 4. 4 times lambda 1, we get minus 2. Minus 4 minus 6, we get minus 6. Or rather, minus 4 minus 2, we get minus 6. Minus 6 times lambda 1, we get 3. Minus 3 plus 3, we get 0. So implying that our remainder is 0. That's fine. So in order to get the final answer here, since recall our factor has got a coefficient of x which is not equal to 1, we have to divide by that coefficient of x, which is a 2 in this case, so that we get the quotient then being x squared plus 2x minus 3. Great. And also by the quadratic factorization approach, and I encourage you guys to check out the quadratic factorization video. We spoke about how to factorize quadratic equations and expressions, but most precisely the expressions. So with that, we know that x squared plus 2x minus 3 is equals to x plus 3 times x minus 1. Therefore, p of x is equals to 2x plus 1, which was the factor we were given already, times the x plus 3 times x minus 1, which we obtained from the factorization method in the end. Great then. So we have our p of x as that and our p of x factorized on the left-hand side. Let's move on to C. So with C, from formula 1, because that's what we have here, from the factors that we have, we are saying that 120 divided by p of x is equivalent to a over 2x plus 1 plus b over x plus 3 plus c over x minus 1. So with that, we clear the fractions by multiplying both sides. The denominator of what is on the left-hand side. In doing so, we are going to have 120 is equivalent to a times x plus 3 times x minus 1 plus b times 2x plus 1 times x minus 1 plus c times 2x plus 1 times x plus 3. Let's label this identity star. So eliminating b and c, we set x is equal to minus 1 over 2 in equation star or identity star. In doing so, we are going to have that and simplifying, we have a is equals to minus 32. Then eliminating a and c, we set x is equal to minus 3 in identity star, implying that we are going to have that and simplifying that So we have 120 is equals to 20b, and simplifying that, we get b is equals to 6. Great. We have our key points here. So the format of our partial fraction, and also the value of a and the value of b. So in this case, we are eliminating a and b. We set x to be equal to 1 in star. So that is what we would have. Then our c is equal to 10. Then substituting for both, in fact, all the variables, a of minus 32, b is equals to 6, and c of 10, we are going to get our final solution as that. If you have made it thus far, thank you so much for watching Numbers Simplified. I'll leave you with the following task. Let me know in the comments section how you solved the problem or the challenges that you might have faced solving the problem. You're always welcome to share also your preferred topics and also the way in which you may want us to look at some of the problems that you may have. One more thing, remember to like, share, and subscribe so that you don't miss out